Hello, everybody. Welcome back to another video. In this video, we're going to be taking a look at a stoichiometry question. Now, funny story, this question I had actually done as one of my first videos back in May. I think it was May 10th. And very recently, I saw a comment by one of my subscribers on my YouTube video where they asked if a calculation I did while balancing the equations was correct or not. And as it turns out, I actually made a very big mistake and the calculation was wrong. So I had to make a video where I correct this mistake. And thank you to that subscriber who spotted my mistake. Well done for that. So here I am. I'm going to solve this question once again. It's a mistake which I should have been completely aware of, but I'm going to do it anyways now. I made an error while balancing equations, and I'll show you where I went wrong so that you can also realize, perhaps you can learn from my mistake, that how important balancing equations is. And when you realize that you've done that step wrong, you kind of, do a face palm because it's such a small mistake and it's so basic. And, when you do it, you feel like, oh my God, what have I done? I've just lost marks. So let's go through this question. So this is a very basic stoichiometry question, comes very, very often in exams. Even though it's so basic, you're going to need it for the rest of your life if you choose to go into the science field, particularly chemistry or biology, or maybe even physics. So without a question, you're going to need this. These topics, they come for 1 or 2 marks usually in the exam, which is quite a bit of marks in the chemistry exam, because in the chemistry exam, all the marks are quite spread out across the paper. No particular question holds more than 3 marks. So such questions are very important, very basic, but very important. So let's look at part A. We've been given an equation over here, which is B2H6 reacts with oxygen to produce HBO2 plus H2O. So this is a combustion reaction. So this is where we combust something. And as you know, in order to combust something, you need oxygen, right? Because I'm sure you've heard of the thing where fires need oxygen to continue. So that's why it's a combustion reaction. You need a lot of oxygen in order to combust or to burn something. So we have this equation over here. 6 plus O2 gives us HBO2 plus H2O. Now, they've asked us in the first part, what mass of O2 will be needed to burn 36.1 grams of B2H6? Now, we cannot simply say that you need 36.1 grams of O2 to burn B2H6. It doesn't work like that, right? That's not how stoichiometry works. You need to first find out the number of moles of oxygen needed, because moles is the standard unit we use to measure matter or quantity or substance in chemistry. That's a standard, metric. That's a standard unit that we use. That's the most reliable one as well. So we have to convert it first to moles if we want to find out the mass of O2, right? We need to first find out the moles of B2H6, and then we can find out the moles of O2 needed to burn that many moles of B2H6, and then we can easily convert moles into mass, and then we get our answer. But before we move on to that step, the very first step we need to do is to balance this equation. Now, sometimes in IB chemistry, they give you the balanced equation and sometimes they don't. So best thing is to make sure that you do have a balanced equation. And if you have been paying attention to this, or if you have been looking over this over the past few minutes, you can tell it's not a balanced equation, right? Because on this side we have boron, we have 2 borons, we have 6 hydrogens, and we have 2 oxygens. And on this side we have 3 hydrogens, we have 1 boron, and we have 3 oxygens. So it's unbalanced. We need to balance it out. So first I'm going to take care of the boron. We need 2 borons, so I'm going to make this a 2. And then the hydrogen also increases by 1. So this becomes 4. This becomes 2. And oxygen becomes 5. Now we need 2 more hydrogens. So I'm going to put a 2 over here. That gives us 2 more hydrogens. That's 4. That's 4 hydrogens over here, plus 2 hydrogens over here, which gives us 6 hydrogens. And the oxygens, we have 4 oxygens over here, and we have 2 oxygens over here. So 4 plus 2, that gives us 6. Now we have balanced boron, boron and hydrogen on each of the sides. Now we need to balance the oxygens. So we have 6 oxygens on this side and we only have 2 over here, but it's going to be easy to solve that. We just have to put a 3 over here. So it becomes 6 oxygens. Now the mistake I had made earlier was I had put a 2 over here instead of a 3. So I had completely missed out on the oxygens in this H2O over here. I had completely missed that out. So that's a very silly mistake on my part. So now I have corrected it and we can move on to solving this problem accurately. So now that we have a balanced equation, we need to first find out the number of moles of B2H6 in 36.1 grams. Now the formula for finding moles is this. Number of moles is equal to mass, small m in grams, so mass in grams, divided by molar mass of the substance. If you do not know this formula, that is completely fine. You may be new to chemistry or you may have done chemistry for some time, but I did not know this formula until I was midway through IB year 1. And that is when I really learned about this formula, because I never paid attention in class, which is, by the way, a very bad thing to do. I have learned from my mistakes now. But you know, the thing that I always tell people who come to me for help is it's never too late to learn. If you have not paid attention in the past, if you think you're far behind the others, if you feel bad for not paying attention, you know, that's completely fine. It's never too late to change. You can always learn and progress on and catch up with the rest of your classmates and maybe even exceed them. So always okay to learn, always okay to ask questions. So let's calculate the number of moles of B2H6. So number of moles will equal to the mass in grams. We've been given that. We have 36.1 gram of B2H6, and we divide this by the molar mass of B2H6, which is 27.66, I believe. Yes, 27.66. And we get the number of moles as approximately 1.3 moles of B2H6. Now, how many moles of oxygen is that? Well, according to this equation, the molar ratio, so if there is no number written over here, it's basically a 1. So the molar ratio of B2H6 to oxygen is 1:3. So that basically means that every 1 mole of B2H6 burned needs 3 moles of oxygen to burn that much, if that makes sense. So if I burn 1 mole of B2H6, how much oxygen am I going to need? I'm going to need 3 moles of oxygen. And we are told that by our balanced equation. That's why this equation is so important. These numbers over here that are put before each of these substances, these numbers, these are your molar ratios. They tell you how much one substance is going to be present in this reaction when compared to another. And that is why it's so helpful. So that's why it is absolutely important that you first balance the equation and you get these numbers correct. Because if you don't get these numbers correct, like I did in my previous, where I solved this question earlier, then your whole thing's going to be wrong. So the ratio of B2H6 to oxygen is 1:3. So every 1 mole of B2H6 requires 3 moles of oxygen to burn. So if we have 1.3 moles of B2H6, we need to multiply this by 3. And that gives us 3.9 moles of oxygen. So 3.9 moles of oxygen is required to burn 1.3 moles of B2H6. And 1.3 moles is the same as 36.1 gram. But we can't use grams directly because moles is the unit, not grams. Grams is not going to give you an accurate answer. So don't try to use grams to calculate the mass, okay? Use moles. So we have we need 3.9 moles of oxygen. Now we can use the same formula to find out how many grams of oxygen we need. So if we know one variable, we know we need 3.9 moles. So N is moles. We know the molar mass of oxygen is 32 because it's O2, right? So it's 32. And the mass, which is mass in grams, is X. We don't know what that is. So simple math over here. We just rearrange, multiply both sides by 32, this cancels out, multiply this by 32. And X, or mass in grams of oxygen, is equal to approximately 125.29 grams of O2. That is our answer for part A. Hopefully, you have understood what I've done. If you do not understand this, please feel free to reach out to me. There is no shame in doing that, no shame in learning more. It's completely fine if you don't understand. I'm here to help, right? So reach out to me and I will help you out, explain it to you in the best way that I can. Now let's move on to the next part of this particular question. Now the next part I had gotten right. I hadn't made a mistake with that, but nonetheless, I'm going to solve it once more so that you guys can use this if you need. So we just need the same equation. I'm going to leave this equation, balanced equation up here. I'm going to just solve this for this. The answer was 125.29 grams. Now for part B, how many moles of water are produced from 19.2 grams of B2H6? So first things first, let's convert grams into moles. So how many moles does 19.2 grams have of B2H6? Well, we know the formula for moles, grams divided by molar mass of B2H6, which is 27.66. This gives us the number of moles as 0.694 moles. Okay, now let's look at the molar ratio. For every 1 mole of B2H6 burned, we get 2 moles of water. Look at the ratio. So 1:2. And again, if there is no number here, it's a 1. We just don't write the 1. You can write it if you want, but we don't typically write it in chemistry. So it's 1:2. There's a 2 here. So for every 1 mole of B2H6 burned, we get 2 moles of water. So really, all we need to do now is multiply 0.694, which is the number of moles of B2H6 burned, by 2 to get the number of moles of water produced. And this gives us an answer of 1.388 moles of H2O. And that is it. That's how simple it was. 1.388 moles. That's it. And you have got your 2 marks already. So that's it for this video. Thank you so much for watching. Once again, thank you to the subscriber who found my mistake. I always appreciate it when someone can spot somewhere where I have gone wrong, because that tells me that you understand the concept now. And at least I have helped you understand it, or you understood it from before, but that is a good thing for me to know. So thanks a lot for watching. I will see you in another video with another question. And as usual, if you have any other queries about this concept or any other concept, please feel free to reach out to me. I'll be more than happy to help you. Send me your questions on Instagram, send it to me by email, put it in the comments below. And that's it. Take care. Goodbye.